Good afternoon, everyone, and welcome to Breakout Track C. My name is Yashar-Ghiassi-Farrokhfal. I'm an assistant professor at Rotterdam School of Management at Technology and Operation Management Department. I'm also an academic director of Smart City and Smart Energy at ECTA, and I'm co-directing this department together with Wolf Ketter from University of Cologne. So in this presentation, I'm going to walk you through some of the challenges and issues that we are facing in the energy system. And particularly, we want to focus on those challenges that are that we are facing that are somehow related to digitalization and artificial intelligence. So let's start with the few pictures that shows that how the traditional energy systems is revolutionary, changing towards something that's entirely different from what we used to see. In the left-hand side, you see all these wires, you see this polluting energy system, you see polluting transportation systems. But then we are undergoing this transition towards green energy, green transportation, use of solar system, and these are only few features of what you can see, what you have seen. But there is way more than that that's happening in energy system, and this is basically what is called smart grids. This is also the focus of this presentation. And basically what I'm going to do is that I will focus on three main pillars of energy systems that are changing, and they are the main reasons behind why energy system is going through these major structural changes. These three pillars are known as 3D, or digitalization, decarbonization, and decentralization. Even though these pillars are evolving independently and they have their own features and their own importance, there are huge interactions in between these pillars, and the proper design and optimal decision making should account for the interactions in between these pillars. And this is important that we do it from the very beginning at this point so that we don't miss any opportunity for the best decision making. So what are these pillars? I'll start with decentralization. Well, decentralization is basically a paradigm shift that is happening in both supply chain and value chain of energy systems. What we used to see in the traditional energy systems, you can see on the left-hand side of the figure, that we had centralized energy power plants, and they're mostly fossil fuel power plants. And they produce large amount of electricity, but they are far from where it is going to be used. So we need another network, which is called transmission network, to transfer electricity from where it is used to where it is going to be consumed. And transmission network is basically this big towers that you see in between cities that they take, and some transformers that they take electricity from power plants to commercial size or the industrial energy consumers. And a portion of these energy consumers are the retail consumers, such as households. And for that, you need another network, which is called distribution network, that you need to further break down the electricity into lower voltage that these end consumers can take electricity. And this distribution network is something that you see within cities. And for example, in Rotterdam, Stedin is the one who is owning this distribution network. So the traditional energy system was centralized. It was fossil-based. It was heavily regulated because of the heavy installation costs of both transmission and distribution network. There are natural monopolies, and that's why they were regulated as semi-governmental or governmental entities. And you had passive consumers. These consumers are only taking energy, and they're inelastic. They don't really react to energy supply and demand matching or to electricity prices. They were unidirectional, meaning that the electricity was produced in one point and they were going through the end consumers, and they were designed mostly in isolation with disregard of the other electricity networks in other countries or the other energy carriers such as heat network and gas networks. But this is structurally changing. And you see some of the examples on the right-hand side of this figure that by the evolution of solar PV panels, the end consumers are basically no longer passive consumers. They become active prosumers, which both produce and consume energy. And they turn unidirectional energy flow to bidirectional, because each point can be energy sink or energy source at different point in time. With the evolution of energy storage and proliferation of that, you can also have the concept of virtual power plants or and also self-sustained microgrids, in which you can consume and produce electricity in local communities. And this is the concept of decentralization. And you rely less and less on the national grid. And you reduce the cost and the energy loss that you'll incur if you want to use a national grid. So what you see in the right-hand side in the future of energy system or power system is that you'll have a decentralized network. It's renewable based instead of fossil based. It is deregulated because deregulation helps to create innovation. And in fact, in both wholesale level and retail level, what we'll see is that all countries have started to deregulate the energy value chain. And we have active prosumers instead of having passive prosumers in the traditional system. We have bidirectional energy transfer, and in order to unleash flexibility to make sure that the energy supply and demand is happening at all time, we need to have an integrated design, meaning that not only we need to account for the different energy carriers, such as heat and gas and electricity, but also you need to account for different flexibility that you can gain by interconnection of local communities, and also in the national level by interconnecting different wholesale markets. So this is, if you think about this decentralization, what you'll see that one of the main reasons that decentralization was happening or was incentivized was by the evolution of decarbonization and the decentralized renewable energy generation, such as solar panels and wind turbine, and the opportunity that you can produce energy at the location that you use energy or you need energy. But as time goes by, you need to have a smart design and a smart operation of such systems, such that this system can be reliable and they can be self-sustained and they can be economical. So decentralization, while a paradigm shift and independent pillar of future of energy, it is heavily dependent on both decarbonization and digitalization for intelligent design. So let's now focus on the second pillar, decarbonization. Well, if you think about energy system as a whole, and not only power system, when because of Paris Agreement, we need to reduce CO2 emission of the entire energy system. Many solutions are proposed, including displacement of fossil fuels with renewable. But that's not only the only solution. There are also other solutions, such as increasing the efficiency, switching to liquid gas, carbon capture, utilization, storage, behavioral studies, or using smart charging for grid stability. None of these solutions in isolations is enough to reach the CO2 emission targets that we have for according to Paris Agreement. And indeed, all of these solutions should be considered and coordinated such that the energy systems entirely can reach the CO2 emission reduction targets that we have. So this is the reason that the concept of sector coupling was evolved, which says that the main energy sectors including power sector, building sector, transport, and industry, should be coordinated and should be designed together such that you use all the flexibilities in between these sectors and all the synergy in between these sectors, so that you can reach the decarbonization target that you have. And this concept was first used in Germany to mean electrification. In other locations, that was a similar wording was used for it, which was system integration. But what it means is that you should use the flexibility that you have in between these sectors. And this example here, it shows a very good scenario that how these sectors can interact with each other. Suppose that we have a solar PV farm or a wind farm that you're using to serve your electricity demand. Because of the intermittency of this type of renewable sources and their diurnal effect, we see that often the case that we have more electricity that we can use momentarily. What is happening in many locations today and in many occasions is that the surplus electricity is curtailed, which will directly affect the financial viability of these renewable technologies. What can be done instead in sector coupling or system integration is that the surplus electricity can be used to serve your heat demand in CHPs or district heating. Or it can be electrolyzed to create hydrogen, and hydrogen is a great feature of future of energy because of several applications that it has, that it can be used to serve transport demand in hydrogen car, and it can be used for CHPs to serve either gas or heat or electricity demand, or it can be further using methanation to be either used in transport sector or to be stored, or to be used in CHPs to serve electricity and heat demand. So importantly, all of these sectors, power, transport, building, and industry, they have elements that they can use to interact with other sectors. And these elements are growing every day and they're becoming more and more mature. Examples of such are Power to X, smart charging, vehicle to grid in transport sector. In building sector, we have district heating, heat pumps, electric boilers. And in the industry sector, we have waste heat to district heating, flexibility, and flexibility to power sector. And the list is growing every day. So in short, this is a great opportunity. You have many sectors, many energy sectors. If you have the chance to identify which sector is easier and more cost effective to be decarbonized, it's better to move energy from one sector, from other sectors to that sector. And that's the concept of electrification. Indeed, power sector is a sector in which decarbonization can be done very cost effectively because renewable electricity is everywhere and it is cheap. And electrification has been shown to save 200 billion euros by 2050 in Germany only. And the projections show that the largest scale electrification of 43% of the entire energy demand in 2050 would be only from electricity, 63% of which is wind and solar. And this, of course, improves flexibility and reliability. And another important aspect of it is that it reduces energy independence. It improves your energy independence, which is quite costly in EU. And finally, it can create millions of jobs. So these are all good, but there are also some limitations to that, of course. Well, to start with, not all sectors can be electrified, such as aviation and high temperature heat. If we move towards electrification, electricity demand increases by 6-fold because other energy demands they're also moving towards electricity demand. And finally, renewable electricity is the main share of electrification resource and is intermittent. So we need more flexibility if we want to electrify. So all of that means that if it's good to have sector coupling for decarbonization, and indeed decarbonization cannot happen efficiently without sector coupling. But at the same time, this requires huge coordination and huge intelligence and smartness. So this shows by itself that why decarbonization is also dependent on digitalization. In short, so far we have said that the decarbonization and decentralization are co-evolving, they're dependent on each other, and at the same time, they're highly dependent on digitalization if you want to have a proper design and proper decision-making. So even though that these two pillars of decarbonization and decentralizations are dependent on digitalization, digitalization was not evolving in energy sector only because of the need of the two other pillars. It was growing by itself as an independent entity. This figure provided by International Energy Agency greatly show how internet traffic and digitalization is surrounding us and is growing day by day. In a matter of 2 decades, we see that internet traffic is growing by 3 orders of magnitude every decade, from petabytes, which is 10 to the power of 15 in 1997, to zettabytes, which is 10 to the power of 21 in 2017. And since 2015, it has been tripled. So it has an exponential growth. It continues to be like that. Also, another aspect is that technology costs are also declining. Since 2008, data collection, storage, and transmission costs have declined by over 90%. In energy sector, this is added to the fact that EV batteries and utility scale PVs are also declining in their cost. So they're becoming more and more affordable. And this is why that we see that digitalization is growing very fast in energy sector. In this figure, you see some of the examples. So far, we have seen AI to be used for prediction optimization for energy demand, energy production, electricity prices, gas prices. IoT is used for control and connectivity in smart building and smart cities. Smart charging is used for grid stability and connecting with transport sector. You have smart metering and smart devices in building and industry sector. And blockchain is the connecting link between decentralization and digitalization. And so far, it has shown great promises in improving grid stability and efficiency and sustainability. And it can be used definitely for optimization, prediction, control, maintenance, safety, remote monitoring, and the list is growing. For example, in building sector, just to give you some numbers, smart buildings can reduce energy by 10% by 2040. This is a report by International Energy Agency. And examples of such that they can have this improvement are smart thermostat that play with the on-off schedule without affecting the comfort zone of the occupants. Smart demand response, which is doing similar thing with electricity demand, and it helps this digitalization in building helps in enhanced measurement, reporting, and monitoring. In transport sector, digitalization helps in connectivity, shared mobility, and automation. Interestingly, the report has shown that the energy demand could be reduced to half of what we have today, or it can be doubled from automation and connectivity, depending whether we are having an intelligent design or it is ill-designed. And digitalization can also affect energy use and CO2 emission reduction of truck and logistic by 20 to 25%. In industry, apart from the effects of digitalization on energy demand and CO2 emission, there are also other aspects that are interesting. Two of such examples are 3D printing, that shows that we can reduce metal demand in aircraft industry by almost 90% by 2050 only through 3D printing. Digital twins also are very helpful in industry sector. They can be used for virtual feasibility and durability tests, and these can save time and resources. In power sector, digitalization helps in reduction of capex and opex. 80 billion US dollars in capex and 5% in annual power generation cost has been shown to be reduced in power sector just because of digitalization. So this was how digitalization is helping decarbonization. But now in how digitalization is helping decentralization, there was a very nice pilot project that was reported by IEA, in which there were 1 billion households and 11 billion smart appliances. And they showed that in such a setting, smart demand response could provide 185 gigawatt of flexibility, avoiding $270 US dollars of new investment in electricity infrastructure. They also showed that EV smart charging would save between 100 to 280 billion dollars of investment in electricity infrastructure. And finally, digitalization could reduce curtailment by 7-fold. This is not the only role of digitalization. As I mentioned earlier, blockchain is a great link between digitalization and decentralization, and there are multiple applications for it. For example, in peer-to-peer trading, or also called transactive energy, they've shown that blockchain can play a big role, unleashing flexibility while preserving your identity. There are several pilot projects on that. Blockchain is also explored on other applications in the energy sector, including energy storage operation market, renewable energy credit trading. There's a quota on CO2 emission of companies, and if they go below or beyond that, they can trade the leftover or surplus with other companies. And there are also multiple studies and pilot projects and studying blockchain, or the role of blockchain on EV charging, reservations, and billing. So all in all, digitalization is needed for energy systems for sure. But there are also some challenges that slows down the speed that digitalization is growing in the energy field. Here is a list of some of the known frictions already. Lack of public acceptance and trust. Of course, it's needed for the adoption of technology, but not everyone is happy to do so at the moment. Economic disruption, there will be some job losses, but at the same time, there will be some new job creations. The market design challenges, of course, because the market is changing to a new form and the market is deregulated. Should make sure that the market is designed in a way that it doesn't allow market manipulation. It is efficient. And the last 3 points I'm going to talk a bit more in detail: additional energy demand, cybersecurity, and data ownership or privacy. When we talk about the energy demand of digitalization, there is an interesting dilemma in using ICT for energy. Indeed, energy largest investment is currently on ICT, and ICT's biggest concern is to procure energy. Data centers account for 1% of the total electricity use currently. As you can see in the right figure, though the global internet traffic, the global internet traffic is growing. As I said, it's tripled since 2015. But what we see is that the energy demand has remained flat. And the reason behind is that there is a great improvement on the efficiency and the other reason is the use of so-called hyperscale data centers. So because of these two reasons, even though that the energy, ICT and the use of ICT is growing, the energy demand of data centers remained almost flat. But the bad news is that these two solutions are becoming saturated. Energy efficiency improvement is slowing down already, and there are limits on shifting to hyperscale data centers. So soon we'll reach to the point that increasing digitalization will also lead to increasing more energy demand. So we need to find other solutions for that, or we need to account for these changes. The other challenge of digitalization is the uncertainties in multiple dimensions, including policy, technology, and behavior. Of course, how the energy systems are reforming in future are highly affected by the policy and how the new technology will evolve, and how people react to the new technologies. And any deviations from what is projected can have major implications on the future investment and operation decisions. And this is very difficult to account for all of that, and that creates uncertainty in digitalization. And finally, security risks and privacy risks are also very important to many companies, especially. In terms of security risks, when you're moving control from a manual control to automation, the cybersecurity attacks, the possibility of cybersecurity attacks increases. There are so many so far of such attacks. Maybe one notable exception is the malware called Indestroyer, which was in Ukraine in 2016, which was attacking electricity system. And it could view, block, control, or destroy control equipments, including circuit breakers. But as we move more and more towards digitalizations, of course, the possibility of having such security attacks increases. And another important element of challenges of digitalization, privacy risk. Not all companies and people are willing to share the data. If you know that your data can be used to detect many things about you, including the occupancy, for example, at your household, then you might not be willing to share your data if you know that the benefit of that is limited. So, of course, half an hour might not be enough to go in deep discussion of everything I pointed out in this presentation. But I just wanted to give you a glimpse of the research topics that we're interested in and we are actively following. And to wrap up, what I wanted to say is that energy systems are revolutionary changing, and there are three pillars behind it: digitalization, decentralization, decarbonization. And digitalization, if not the main pillar, is one of the main pillars, and there are some limitations and there are some frictions to go for more digitalization. And it is important to identify those barriers and to remove them to unlock the potentials of all of these pillars. If you want to discuss about any of these topics, I will be happy to have conversation with you. Please stay connected. My email address is down there, y.ghiassi@rsm.nl. I'm not sure. I guess we have maybe time for one question or two.
Yes, that's right. Hello, Mathieu here. I'm the moderator for this talk. Thank you very much, Yashar. Questions are coming in from the audience, and I think we have time for just one question, so I'll keep it to one. Someone is asking, among the four sectors you mentioned, the power sector is the most economical and the easiest to be decarbonized. Which sector, in your view, is the furthest away from being fully decarbonized? Okay.
Thank you, Matthew. It's a good question. So what, let me see if I have the slide. Okay, so maybe this will help a bit. So in my view, transport sector is a sector that has the largest or the most difficult one to decarbonize. It has the lowest share of renewable energy use. That's 94% oil-based, and electrification in this sector is very challenging. Not all of these subsectors can be electrified. Passenger cars is the sector that can be electrified. Sorry. Is a sector can be electrified, but road freight, aviation, and shipping are the subsectors that are very difficult to be electrified, and there are other solutions that are being considered for decarbonization, such as LNG, biofuels, and hydrogen. I don't know if that answered the question.
Thank you.